Yeah, so I'll just wait for 2 minutes and then I'll introduce first and then I'll ask you to take over. How many participants? Today we have registered about 100 participants. Hello, recording. Okay. Two minutes. Good morning to all participants from India. Good afternoon for all participants from China, Japan, Cambodia, Thailand, and other places. I am Dr. B.V. Mehta, the Secretary General of the International Association of Rice Bran Oil. IARBO has started the lecture series to promote the awareness about the rice bran oil as a good cooking oil. Today is the second lecture. Dr. Hai Hang, the technical manager of Wilmar R&D Center China. He is PhD in applied chemistry of Henzing University of China. His major research interest is of food safety, new technologies, and equipment for gaining and oil processing, etc. I request Dr. Hai Hang to start his presentations. Over to Dr. Hai Hang.
Okay. So, Dr. Mehta, thank you for your invitation and for your kind introduction of me. And here today, I'll give you a brief introduction of the mineral oil contaminants. And it will include the historic background of the mineral oil and the composition of the mineral oil hydrocarbons and the toxicity legislation and survey data, and also includes the possible sources of the mineral oil hydrocarbon in edible oil supply chain. And at last, a brief introduction of the summary will show. So I hope the presentation and the brief introduction will help you to get an initial and a basic picture and understanding of the mineral oil in the food, especially in the edible oil. So let's see the historic of the background of the mineral oil in food. So from the timeline, we can see that the mineral oil issue is not a new topic. So in recent years, the market, especially the Europe and the Europe Food Safety Agency has paid more attention to the mineral oil hydrocarbon contaminants in food, especially in the baby and children food. And they has published a few scientific papers and reports on the mineral oil hydrocarbons in food including the occurrence, risk assessment, and some research data. So if is put in force the regulation on the way, I think maybe the regulation will come in force within next 2 years. So let's see the mineral oil hydrocarbons. It can be divided into two class groups. One is the saturated hydrocarbons, we call the MOSH, and the other one is the aromatic hydrocarbons, we call the MOA. And the mineral oil hydrocarbons comes from the crude mineral oil after the petroleum distillation and the refinement. So there are two grade mineral oil products. One is the food grade one. It has no MOA. But for the technical grade mineral oil, it contains 15 to 35%. So they are different. So in the food processing, I think we can use the food grade mineral oil to avoid the MOA contaminants. So let's see the molecular structure of the MOS. The MOS contain two main groups. One is the alkanes, and the other is the and they are both saturated hydrocarbons, and they are very lipophilic and inert in the chemical properties. And also for the aromatic hydrocarbons MOA, it contains more than one aromatic rings, and it also contains one the alkyl groups of the tail. And the molecular, we can see that are like the polymetric hydrocarbons, but they are different, especially the more branched or unbranched alkyl groups. So from the molecular structures, we can see that the mineral oil hydrocarbons are very complex, and the number of the isomers increase exponentially with the number of the carbon numbers atoms, and the numbers of the mineral oil hydrocarbons can be over hundreds of thousands. So it's very complex. Currently, there are no method to separate all of the mineral oil carbon molecules into the individuals. So because it's too complex. As we know that the mineral oil has been widely used in the industry, such as the food processing, the mechanical, electrical, and the food packing materials, and the cosmetics, and even the biomedicine, the pesticides, and the animal feeds. So from the usage of the wide usage of the mineral oil, we can say that the mineral oil has many different entries to migrate into the food from different metrics. So after 10 years, IFSA has published a new report on the update of the risk assessment of MOSH and MOA in food. And for the risk assessment summary for the MOSH, we can say that it turns out that the current dietary exposure towards MOSH for all age classes raises no concern for human health. So it means that based on the current data, especially the toxic data, it shows the MOS has a much lower health concern, but still the IFSA recommended that more data of MOS are also needed, includes the toxicity of the highly acclimating MOS and the effect on the lipoprotein and the inflation, and the effect on the toxicity of the metabolites and the tissue concentrations in humans. But for the MOA, the risk is much higher. It tells that the MOA with 3 or more non-unstable oculated aromatic rings may be mutagenic and carcinogenic. So it is of potential health concern. So compared to the MOS, MOA has much higher risk we should pay attention to. Also, the IFSA recommended that more data of the MOA are also needed, especially including the MOA in food by aromatic ring number, the effect of ring oxidation or genotoxicity, the toxic for 1 to 2 ring MOA. So for the toxic assessment, much data and more data of MOS and MOA are needed. So for the legislation, we can see that there is no EU legislation for the maximum limits of the mineral oil hydrocarbons, especially in the vegetable oil and fats. But we see that the MOA possesses the high potential health concern, and especially IFSA pay more attention on the MOA. So based on the confirmation of the genotoxicity data of MOA, IFSA will put the maximum limits of regulation be forthcoming. I think maybe it will come true within 2 years. So we should pay attention for the MOA in the edible oil and the fats. So although there is no the official regulations of the maximum limits of the MOA and the mineral oil hydrocarbon in Europe, but the IFSA recommended that the MOA levels in food should be focused. So it can be divided in 3 categories based on the fat content in this food. For at first, if the fat content below 4% in the food, the MOA should be below 0.5 ppm. And if the fat content is higher than 4% and below 50% in food, the MOA in the food should be below 1 ppm. And the third, if the fat content is higher than 50%, the MOA in the food should be below 2 ppm. But we should pay attention that if the IOQ of the analytic method is much lower, and this value, the maximum limits, I think will be decreased. And for the standard analysis method for the mineral oil hydrocarbon, it is available. That is the online HPLC GCFD analysis method. And in 2019, Wilmar Shanghai R&D Center has installed this device. And now we can determine the mineral oil hydrocarbons in the edible oil and some solid matrix like the infant formula. So here is an example of the spectrum of the MOS and MOA results in the crude coconut oil and lubricant. And for this method, it can separate MOS and MOA in the edible oil samples, but it can't separate currency between the different capital number. So our colleague, Dr. Wang Yan, will give a detail and the analysis precise will give a detailed introduction next week. So for the occurrence of the mineral oil in food in 2012, IFSA has collected many different food samples in European region market. And from the figure, we can see that the IFSA has collected 515 samples, and we can see that the MOS in the vegetable oil samples is about 45 ppm. Is the average value, and it's also found that the oil, peanut oil, has the maximum content about 680 ppm, and the carbon number is in the range of 18 to 35, and centered at 27. So we can see that the mineral oil was widely used in different area in the industry. So it can be introduced at each step of the edible oil supply chain. So for example, at the agricultural stage, the link of the diesel or lubricant from the agricultural vehicles, the pesticides contain mineral oil hydrocarbon, and even from the environment, for example, the exhaust gas from the vehicle, even in the soil. And the second is storage of the seeds or beans. And there are also some pathway. One is the anti-dusting agent, and a link of the diesel on lubricant, and also drying with the food or diesel fair combustion gases. And importantly, the migration from the packing materials. The third one is transport of the seed beans. It includes the anti-dusting agent and the environment, especially from the tails and the road tar, and the links of the diesel or lubricant from the transport vehicles. For the fourth step, especially for the edible oil refining plants, the mineral oil links from the lubricant, especially the crushing machine, refining the pump and the tank. So, and also during the materials produce, there's some risk, link risk of the lubricant from the machine. And the last, the transport of the oil is also there's some risk. For example, the contamination by the curious cargo and the links from the equipment, for example, the pumps. So from all of the entire supply chain of the edible oil we can see the mineral oil contaminants can enter in this change at each steps. So we need to make many efforts to avoid the contaminants. So let's see the mitigation. For the traditional refining, we can see that the degumming, neutralization, and bleaching has no effect on the mineral oil hydrocarbon decrease. But for the deionization at a higher temperature, the most with the carbon number below 20, it can be completely removed. But for more higher carbon number, the MOS and the MOA it are difficult to be removed from the systems. So we can see from the finger, the lower number of the MOS and the MOA, the MOS can be removed, but the high number, carbon number, here is 27, 29, and even the more higher carbon number. These components cannot removed from this system by the high temperature deionization. And recently, some scientific paper find that the short path distillation can efficiently remove the MOS and the MOA, especially with the high or the larger carbon numbers, atom numbers. But compared with the traditional deionization, it is expensive. So as a whole, the mineral oil control strategy with starting on currently the contamination by the mineral oil hydrocarbon primarily is a supply chain issue and less so a process issue. So we need to make much effort at each step. It is systematically controlled to avoid the mineral oil hydrocarbon contaminants. Okay, here is a brief summary about the mineral oil contaminants issue. Mineral oil hydrocarbons are present at different levels in nearly all foods, especially include the vegetable oils. And the MOA fraction may be both mutagenic and carcinogenic. So we should pay more attention on the MOA levels in our edible oil samples or products. And for the analysis method, it is available, and some new methods are being developed. For example, the WGC 12 months method are discussing. And currently, there are no EU legislation regulating the limits of the MOA in vegetable oils. And I think it will be enforced within 2 years. So we should make more efforts to meet this standard. And the mineral oil may be introduced at a different stage or steps of the vegetable oil and fat productions because the mineral oil was widely used in the industry. And for the mitigation, it's quite difficult to remove total mineral oil as a traditional refining, even with higher deodorization temperature. So maybe the short pass distillation can give us a method or solution for the mineral oil removal, but the cost is higher than the traditional refining process. Okay, thank you. Any questions?
Stop sharing so that question can be put on chat box.
Yeah, so if you have questions, you can feel free to input the question in the chat box.
I have one question. How we use the food grade hexane in solvent extraction process? How do we check that there is no contamination of hexane with the vegetable oil? What are the steps required?
Yeah. So in our Shanghai R&D Center, we can test the MOSH and MOA in the hexane from our data that the hydrogen solvent, especially at the initial stage, there are no and MOA we cite with the high the larger carbon numbers, and we also checked the white oil when we use the white oil to absorb the hydrogen during the solvent extraction. So there in our plants there are no or the little risk of the mineral oil contaminants.
So what's the safe limit? What is the safe limit? What is the safe limit of contaminations in a vegetable oil? So the food hexane is mixed with the vegetable oil. What is the safe limit? Up to what limit we can allow? Is it clear? Or should I repeat?
Sorry, can you repeat it?
Doctor, what I'm asking you, if food grade hexane, what is the safe limit for edible oil? What is the ppm can be allowed in the maximum allowed in the refined oil?
Currently, there's no data about this issue. So we just the crude oil. Okay. Yeah, there is no currency relationship between.
You have some questions. You can look at the chat box.
上海博士那个蚕蛹限量的话，没有法规吗？蚕蛹？
在油里边是有的，在中国的话，我印象里是200个 ppm 还是100个 ppm？
Oh, you can use English.
Yeah, Dr. Mehta. For the limits of the hydrogen in crude oil, I remember that it's about maybe below 200 ppm.
Okay.
Yeah.
Okay. Now, doctor, you have some question. You can look at the chat box.
Okay. For the analysis method, I think there is no the economic or cheap method currently, because we use a special analysis device. Maybe the device is called maybe I think to more than 2 how to see in RMB more than 150.
There are some more questions for you.
Yeah. And for the another question, can you track red spray for MOA before extracting oil from it?
From down.
Yes. We can do this in the live to check the red spray for the MOA level.
Okay.
Okay, can I ask this question?
Yeah.
I have a question. I think it
Can
would
you
be.
identify yourself? Can you identify yourself?
Yeah, my name is Dhananjay Tokekar. I'm working with Alpha Level, India.
Yeah.
Yeah, I'm an oil technologist and working in this field for last about 25 years. My question is, the mineral oils, they are these hydrocarbons, petroleum products, and normally what we see is their vapor pressure or their boiling point under vacuum in deodorization is around or maybe 180 to 200 degrees centigrade.
Yeah.
Okay, and the deodorization temperature is 240 to 250 degrees centigrade. In case of palm oil, it could be a little higher.
Yeah.
So my question is, all this mineral oil, whenever or wherever it gets contaminated with oil, with rice bran or with soybean or with palm, whichever oil from extraction to refining, I suppose that this will get removed in the deodorization step fully, because our deodorization time is also about 1 hour or 45 minutes.
What's your question, Dhananjay?
My question is,
Yeah.
my question is, in the refined oil, we don't find any traces of mineral oil when we go with the contamination test. So I think that is the reason. But then I saw in one of the slides that there are mineral oil contaminants in the products where we use refined oil. So I was having this doubt.
Okay, thank you for your good question. So based on our analysis data, among these oils, the palm oil and the coconut oil had the highest level of the MOSH and MOA. And but for the seed oil, like the soybean and maize oil, rapeseed, presents lower levels of the MOSH and MOA. And because you can see that from this figure, we can see that at 200, about 240 degree deodorization, the carbon number with the carbon number 23, the MOSH can be completely removed, and about 50 carbon number 25, the occurrence can be removed, but higher carbon number MOSH can't removed by the deodorization. Is even with higher deodorization, you just mentioned that the palm oil, the deodorization temperature is about 250. Is especially higher than other oils, but we see that the palm oil has the highest level of the MOSH and the MOA. So I think the MOSH and MOA with the larger carbon numbers, because of the boiling point, is much higher. So the traditional deodorization conditions cannot remove all of the MOSH and MOA with the higher carbons. Maybe if the MOSH, the carbon number is larger than 30, maybe I think the deodorization cannot work. for this issue.
Okay. Next
So,
question.
I think if the refining tank or the vessel will can use the much lower vacuum, maybe I think it will make a contribution to remove of the motion and MOA. And you can see the short pass distillation has much lower vacuum, even maybe I think 0.001 millibar.
Yeah, that's right.
Yeah, so all of this motion and MOA can be removed.
Yeah,
completely. Yeah.
Doctor,
thank you for your answer.
Thank you, Dhananjay.
Thank you.
There's one more question for you from Asif Ansari. A very relevant question by Mr. Alpha Level. That's of course, is any new questions? Ask Mr. Asif Ansari from Pakistan. He has a question. Mineral are from pure chemistry definition, inorganic version, paragons, which is are organic. Any interaction here and how? Have you
徐
seen
教
that?
授，徐教授，
哎，
他刚才问题我没有太听太清。
他是说就是在这个脱臼它250度的话呢，它在阿尔法的实践中就是全部脱掉了。它就是刚才你解释了这个问题，就下一个问题的话是奸诈的话，我认为因为像这些分子的话呢，虽然奸诈的温度比较高，但是会发布出去。
Yeah. So, thank you, Professor Chu. So, for the cooking and the frying, the temperature is lower than the traditional temperature at the deodorization. Maybe I think it is about 180 degree, and the standard pressure. So at these conditions, the mineral oil cannot removed from this system.
Mr. Ansari, you have any additional points? Okay, next question. Any other questions? Ansari written further to it, while cooking and the frying, the high temperature should be able to remove any remaining traces. Any comments? He is asking you, Dr. Zhang, do you have any reply?
He just Dr. Zhang had already replied. In frying temperature, actually in normally vacuum, normally the atmosphere. So therefore, those contaminants cannot be removed. Actually, even during deodorization, we usually have vacuum with 250. So therefore, in frying situations, these compounds, volatiles usually below 100, boiling point should be removed. But in this case, cooking will not remove it.
Yeah.
It's much higher boiling point.
Right.
Okay. Any other questions? I think that was the last question. If there is no other question, then I would like to put a vote of thanks. Okay. I would like to thank Dr. Heng for his excellent presentation on mineral oil contaminations. I would like to thank all the participants for attending today's lecture, and let me inform that third lecture in mineral oil contamination series, that is Analytical Progress by Dr. Yang Wing, will be held on next Monday, 25th September at 10:30 IST time. We will issue the link in a day or two and may register as participants. I also thank Dr. Prakosh Datta, the President of the IRBO, Mr. Ajay Junjunwala, President SCA, Professor Zubin, and other directors of IRBO. Lastly, I would like to thank my colleagues, Mr. Ganesh Kaldate, Deputy Secretary, Ms. Anupriya, Ms. Tejaswini for organizing this webinar lecture. Thank you and look forward to see you at the next Monday at the same time. Thank you very much.
Thank you. Thank you.
Thank you. Thank you.
Thank you.
चलिए आज जल्दी हो गया तो मैंने लिखा था
Okay.
Heartiest congratulations, Dr. Zhang and Dr. Mehta. This was excellent. I know this is over, but I must congratulate you. Let's do consider another burning topic, TFA, that we could cross every now and then. I know we are closed for that now at the moment. Please do consider that. Thank you. Have a wonderful time and a wonderful day.